Hi everyone, this is Autumn, and the mathematical task I'll be talking about today is called creating and describing shapes. Now, this task is a kindergarten task, and it meets the standard that states to correctly name squares, circles, triangles, rectangles, hexagons, cubes, cones, cylinders, and spheres, regardless of their orientation or overall size. This standard begins teaching students about the different attributes, so they're learning how to describe shapes. They're talking about the number of vertices, angles, the number of sides, and then going into whether those sides are equal or unequal. Students will also be able to describe 2D shapes in details using math vocabulary, so that was described earlier, and then they'll be able to identify and build 2D shapes correctly based on the shape description. And I use this task specifically for describing 2D shapes, but again, you can use this task for whatever you're trying to get your kindergarten students to focus on. For materials, this involves using a geoboard and then having a few rubber bands per student, or you can also use the source that we talked about in class, so from the Math Learning Center, and using the online geoboard. Now, this task does involve working in partners. So one partner is going to describe the shape attributes to another student, and then that partner will build the shape on their geoboard based on their partner's description. Then once that shape is built, both partners are going to look and see if they each built the shape that they thought they were describing or that was being described. And then finally, students are going to switch roles. And so one partner will then get to build the shape and the other one will get to practice describing it. Now, I'd like to show you guys how this would be done using the online resource that we have. So again, we've been to this website and there's Geoboard. So let's say I'm partnered up with one student and he says, okay, I want you to build a shape that has 4 sides, 4 vertices, and 4 equal sides. So once I hear that equal, hopefully a student will know, okay, 4 sides, 4 vertices, and 4 equal sides. That has to be a square. So I would show my board to my partner and we would both agree and talk about why they were describing a square. So one student might ask, hey, how did you know that I was describing a square? Were you able to get that? Well, I was able to get that because you said they were 4 equal sides. Let me show another example. Now, let's say you're partnered up with that student again, and they say, I want you to build a shape that has 4 vertices and 4 sides. And that's it. So me being a student, I could be like, okay, 4 sides and 4 vertices. All right, this is what I built. So I would show my partner this. Now this is very obviously a square. So what if that partner was like, no, you were supposed to build this is, I apologize, this is a rectangle. So what if that partner is like, no, you were supposed to build a square? Based on your description though, you said it could be 4 sides and 4 vertices. So what I really like about this task is that students get to defend themselves, defend their reasoning, and they have to be very precise with their language. Because as we've been talking about in class, when we're talking about mathematics, we need to use the right language. We need to use language that will help students in the future. So 4 sides, 4 vertices, that could be a square or rectangle. Another interesting concept that this idea introduces is with triangles. So a lot of kindergarten students' misconceptions are they mainly recognize equilateral triangles and they don't see like isosceles or right triangles as being triangles right away. And this is just because of how they're presented in class. So say you have a student that says, okay, I want you to build me a shape that has 3 sides and 3 vertices. So I've seen this in class where students build a triangle like this. So for example, this is a right triangle, and then the other student says, no, that's not what I was talking about. So this is a great conversation to have with your students that triangles look different ways. So they could be 3 sides and that 3 vertices, and that's what makes a triangle. Not that every single triangle has to look like this one. Not all triangles have to look like an equilateral. So again, thank you so much for watching my task, and I appreciate it. All right, bye-bye.